In this question, we've been told that a car is travelling along a straight horizontal road at time t equals 0, so at the beginning of the journey, it goes past the point A. So this is when we start paying attention to the car, from the point A onwards. And it has a speed of 16 meters per second. Now, as the car passes A, it begins to decelerate uniformly, reaching a speed of 10 meters per second, covering a distance of 104 meters. A lot of information. We should definitely make a diagram. The car then immediately begins to accelerate uniformly for 12 seconds, reaching a speed u, where u is greater than 16. This new speed is maintained for another 32 seconds, which is when the car goes past the point B on this road. First, we're asked to sketch. I would have wanted a sketch anyway, just so we can tell what's going on. We're asked to sketch a speed time graph to show the motion of the car from A to B. Okay, let's go back and break it down. We'll start with some axes. At first, the car was moving with a velocity with a speed of 16 meters per second. Later on, it drops down to 10 meters per second. So I can mark those on the axes. We're told that it decelerates uniformly, reaching a speed of 10, and in that time it covers a distance of 104 meters. So we don't actually know the time that it takes to decelerate. But we'll show deceleration as a negative gradient, a negative slope, and that gets us from 16 to 10. After that, we're told that immediately the car begins to accelerate uniformly for 12 seconds, reaching a speed of u. So I'm going to show some acceleration here, and I've been told that u is greater than 16, so it should get to a speed above what it had before. After that, the car maintains this new speed for 32 seconds. So the new speed is maintained, constant speed, constant velocity. We show that as a horizontal line. Okay, so here are the points of interest, and we can add a little bit more information about each of these. This first time interval, we don't actually know. The second time interval, I'll call it T2, we do actually know. That was 12 seconds. The car accelerated for 12 seconds. And the last interval was 32 seconds of constant speed maintained by the car. So T1 is unknown, T2 is actually 12, and we have 32 seconds. So this is our complete diagram. I can actually just label the axes as well. So velocity and time. Part B of the question says that we should find the total time taken for the car to move from A to B. So we need to find these unknown times. T2 we actually do know, it's 12. We're looking for T1. What information do we have about this first interval of the journey, this first portion of the journey? We were told that it covers 104 meters. Okay, so I'm just going to resketch that first bit. If it covers 104 meters, I can use the fact that the area under a velocity time graph matches the distance or the displacement in that interval. So the area of this trapezium should equal the distance of 104 meters. So I'm just going to substitute in what we know, half the sum of the parallel sides multiplied by the perpendicular distance between them. That's half of 10 plus 16 multiplied by T1. We know it equals 104, and double both sides, simplify inside the bracket. 208 equals 26 T1. T1 is going to divide, that gives me 8. The time interval of that first section is 8 seconds. The second section, T2, is 12 seconds, and we have 32 seconds. So altogether, 52 seconds. The time for this journey is 52 seconds. In part C, we're asked to calculate the value of u, and we've been given the extra information that the distance AB is 1 kilometer. So the total distance for this whole journey is 1 kilometer, or 1,000 meters. So, since I know we've traveled 104 meters so far, these last two sections should have an area of 1,000 meters subtracts the 104 meters. So I'll go again with our diagrams. I can label them and just solve this geometrically. So the total distance should be the area of this trapezium plus the area of this rectangle. Substitute what we know. 1000 minus 104 is 896. And that should be half multiplied by the parallel sides added. That's 10 plus u multiplied by the 12. And on this side, we get 32u. Okay, really have an equation with one unknown, the unknown u value. So let's go ahead and expand the brackets, multiply out, and that should help us to simplify. Rearranging, we get 38u equals 836, and that leaves us with u equals 22.